Good morning, this is Ms. Billerbeck, and we are going to look at section 3.3, transforming linear functions. So first we're going to look at a Desmos demonstration and look at a parent graph of a linear function, and then look and see if we can shift that parent graph horizontally or vertically or both to meet a line, a different line. So let me share the screen. All right, so if we're looking at this, our parent graph is y equals x. So first we have the equation y equals a x minus c. So a is the slope. So we're going to just keep the slope at 1. Okay, so then we have a x minus c. Well, what does c do? So if we look at this, this is our parent graph right here, y equals x. And from this parent graph, all other graphs are created, whether they're created by a horizontal shift, a vertical shift, or a stretch or a compression. So let's first look at a horizontal shift. So that is x, because x is the horizontal axis. So c is associated with that x. So as c, even though it's a minus, as c becomes more positive, it moves it down this axis. So if c is 4, I'm at 4 right here on the axis. Okay, so then if I want to match this red line up to this line, let's see what value of c I would need to do. So it looks like -2 would match it up right here. So c equals -2. All right, so let's look at this one. If we have y equals ax, so the mx plus b form, so ax plus b, so a is the slope, and b is my y-intercept. So the y-intercept moves like this. So as b is positive, it moves up, and as it moves negative, it moves below. So if we went to -4 right here, we're at -4 on the y-axis. If we see that this line that we're trying to match up is at 2, so we could move this b to 2. So we could move the parent graph either solely with a horizontal shift or solely with a vertical shift. So when we did that with a sole horizontal shift, we had -2. When we did a sole vertical shift, we had b was 2. Now, if we look at this equation, y equals a times the quantity x minus h plus k, that is more of a vertex form. You'll see that when we deal with parabolas. So it's a vertex form of a linear equation. So k represents the y value. So it represents our vertical shift. But if we note, even though it was right there it has a shift at 2, k is 5. That's kind of strange, huh? And then h is 3. But we found h, which is the horizontal shift. Okay, so h is at 3 when it all lines up. Okay, but we had c at -2. So it does go through -2 on the x-axis, and it does go through 2 on the y-axis for b. But this is a little different. This is a vertex. So if we wander over, if this is the x value, the domain, and this one's the y value, let's see if I can move that. So there we go. So this is the x, the domain is the h, the range is the k. So if we're looking at x is 3 and y is 5, we go over here to 3 here, and then we go all the way up to 5. Well, there's the point. So that point, 3, 5, is on the line. But what we did when we were solely doing a horizontal shift and solely doing a vertical shift, we were finding intercepts. This is finding a point on the line. It's not necessarily a vertex, because a vertex is a point where two line segments meet, but it certainly will look like the vertex form of a parabola. So that's not necessarily the name of this, though I want you to get used to the form, because you'll see this when we get to the parabolas, where it's called a vertex form of a parabola. All right, let's go back to the lesson. Okay, so we were just looking at transforming the parent. So the parent graph for a linear function is y equals x. So if we remember the point slope form of the graph, y minus y1 equals m times x minus x1, and we move that y1 to the other side, we get y equals m times the quantity x minus x1 plus y1. Okay, now if we substitute slope for the value of a, x1 for the value of h, and y1 for the value of k, then you get something that looks very similar to the vertex form of a parabola, but it's a linear function. So this is y equals a times the quantity x minus h plus k. So it's kind of like the vertex, even though there is no vertex. It's like a vertex linear form. I just made that up, so you won't see that in a book, because there's no vertex. But it's kind of like the vertex. So if you had a little square here, you would have the vertex form of a parabola. But we're only talking about linear equations. So, the vertex would show up right here at HK. So HK is a point on the line. So let's look at what exactly the translating does. So if we translate the parent graph, we have y equals a times the quantity x minus h plus k. Okay, so when we look at h, for h is greater than 0, which means it's a positive h, what we have is the graph shifts right. So for a positive h, the graph shifts right. For a negative h, the graph shifts into the negative region of the domain, and that's left. Okay, if a k is greater than 0, a positive number, it shifts up on the y-axis in the range. If k is a negative number, the graph shifts down in the range on the y-axis. All right, so let's take a look at these equations and plot a few. Okay, so we have f of x equals negative 4x. So at 0, x goes through 0 because there's no y-intercept. It's plus 0 here. So that's the y-intercept. Then we rise negative 4, 1, 2, 3, 4, and run 1. So that gives us our point. We could have also put if f of 1 equals negative 4 times 1. So for 1, our output will be negative 4. which is this point. Okay, so if our output f of 2, we would have -4 times 2, which gives us -8. So we can see we have a pattern going on here. And all points are matching up on the line, so let's draw the line. So now we want to know, how does this shift? So if we have the g of x and it just is -4x minus 3, so now we're just going to subtract 3 from each one. So if we look at g of x, g of 0, we'd have -4 times 0 minus 3. So at g of 0, we don't go through the origin anymore. We go through -3. 0, -3. So let's plot that one. I'm going to use this one. So we're going to be at -3. So let me use green so you can see the difference, -3. Okay, then if we go back to g of 1, we have -4 times 1 minus 3 gives us a -7. So we have a point 1, -7. So we go down here at x is 1, and then we drop down to -7. And we can also, from here, we know the slope of the line's -4, so we can rise 1, 2, 3, 4, run -1, and get our third point that way too, because we know how to do that. So let's graph this one. Okay, so we see that this graph is just going to be just slightly lower than the other graph. Okay, so that would make sense because we have a -3, so it dropped the graph down, or dropped the graph down vertically. So let's take a look at what the next graph might do. So this one we have plus 4.5. So what do we think is going to happen? It's a positive y. So we're moving from 0 up to 1.5. So if we didn't want to do any work, we could just say, oh, I bet that's going to be at 1.5 right here. So if we did h of 0 equals -4 times 0 plus 1.5, we would have at 0, we would have 0, 1.5 would be our y-intercept. If we do h of 1, we have -4 times 1 plus 1.5. So that's going to give us at h of 1, we're going to have -4 plus 1.5. So that gives us -2.5. Okay, so at 1, we're going to be at -2.5 right here. Okay, so that's very close to the other one. And then if we again rise 4, 1, 2, 3, 4, run 1, we have another point right here. Run -1, we have a point right here. And that is right on that line. So let's draw that line. So we just see they're all parallel lines because they have the same slope, which is the definition of one of the definitions of parallel lines. They have the same slope and they never intersect. So these are parallel lines. So this one shifted it up, This one shifted it down. Now, if we look at the horizontal shift, so we see we want to graph this one. So we graph this at the y-intercept of 7, and we have a slope of 3. So we rise 1, 2, 3, run 1, or we rise -3, -1. Okay, we could also plug in a few points if we're not sure. So f of 0 equals 3 times 0 plus 7. So at 0, we are at 7, which is exactly what we had. At f of 1, we have 3 times 1 plus 7 equals 10. So at 1, we should be at 10, which is right where we're at. Okay, so let's graph that. And we have the graph looking like that. So let's look at this shift. Okay, so let's put in a few numbers for that one. So we have g of 0 equals 3 times 0 minus 4 plus 7. So that's -4. So we have g of 0 equals -12 plus 7 gives us a -5. Okay, let's do one more. So that gives us a point right here at 0, -5. Okay, then that's our y-intercept. Then we also know from this that since this is kind of like a vertex form of a parabola, that 4, 7 should be a point. So we're expecting 4, +7 to be the other point here, another point. Because we get our 4 from here and 7 there. Okay, let's find another point at 1 just to see what's going on. So we have g of 1 equals, we have 3 times 1 minus 4 plus 7. So we have g of 1 equals, this is -3. So we have 3 times -3 plus 7. So we have g of 1 equals -9 plus 7, which is -2. So we have 1, -2. All right, so at 1, we are at -2. So 1, -2. And look at that. It's looking like it's in the same boat. The same line. Yay. So that's the joy of that vertex. Well, it's not really a vertex. It's just my name for it. It looks like the vertex form of a parabola. Okay. So, and you are going to see the vertex form of a parabola this year. Okay, so we see, okay, this has shifted over about 4 right here. So if we count 1, 2, 3, 4. So this shifted +4. And it shifted for that direction. Okay, so we would expect this one to shift, but since that's supposed to be a minus, there's a minus -9.5 going on right here. So we're going to expect this one to shift way over into the problem over here. So we'll have to be very careful how we draw that line. All right, so let's look at h of x. So we're expecting it to shift way over here. Okay, if we look at the vertex, or the point here, like point slope. So this is a -9.5, which is right about here, and then at 7. So 7's right there. So we're going to expect this line to go through a point like right there. Wow, that point. Okay, barely wanted to write. Okay, so let's go ahead and calculate a few h of x's. So if we have h of 0, I think I'm going to get a different pen. Okay, so h of 0 we have 3 times 0 plus 9.5 plus 7. Okay, well, maybe I should do a negative number and make it easy on myself. How about -9? I'm just trying to make it easy. So -9 equals 3 times -9 plus 9.5 is 0.5 plus 7. Okay, so then we have half of 3.5 is 1.5, so 1.5 plus 7 is 8.5. So at -9, at -9, we are at 8.5. Actually, that's a little higher than we were thinking right there. We could have, oh, I see. So we had this point here. Okay, so let's go bigger. Let's do h. You see what I'm seeing? This line's going to be way over here. So we want to know what's happening at -12. So we have 3 times -12. This is informed graphing. You look at your 2 points and you realize where the next one should be. Oops, that's at plus 9.5. Okay, so you have h of -12 equals 3 times, then that's going to give us -2.5 plus 7. Okay, so 3 times 2.5, so that's 15, is -7.5 plus 7. So we're at 0.5. So see why -0.5. So at -12, we are right here. Okay, and that should be right in line with those other points. So when we graph that, we see, they are all in the line. So we see we've got something here, we have that, and now we can draw the rest of the line. So we can see that that line is indeed shifted over. And if we measured it at 2.5 to about 12, that's about 2.5 to about 12. That's a distance of a shift of right here of plus or minus 9.5. Okay, so if we look at these again, it's a little harder to see, but this one, the purple one shifted up. The purple one shifted up 1.5, and the green one shifted down 3. This one's a little easier to see how it's shifting right here, where it's shifting 4 over this direction and -9.5 that direction from the parent graph of, or the original graph of this. Okay. So the next slide, we have, we're given this again, and I want to talk about stretching. So the graph is stretched when the absolute value of A is greater than 1. So A is less than 1 and A is greater than 1. When you look at it, the absolute value of A is less than 1. So that's a stretched graph. So a graph is compressed when -1 is less than A is less than 0, and 0 is less than A is less than 1. So what's happening when A equals 0? Well, you have y equals 0 times all this, which it doesn't matter because it's gone because it's multiplied with 0, so it's just equals k. So it's a constant, so you have a horizontal line. Okay. All right, so let's quickly go back to the graph we were looking at. And this time we're going to put everything back to where it was on the parent. Okay, whoops, leaving that one there. Well, I guess I'll put it back there too. There we go. Whoops. So we put this back to the 0. And if we just, the stretch is here. So if you see the A is greater than 1, it stretches. But it also stretches when A, if you go to -1, which is the inverse of that graph, and then it's stretching that direction too. So we don't want to forget about the negative stretch. Okay, and then in between, when it's less than 1, we see that it's compressing and it's getting closer to the x-axis on both sides here. So at 0, though, we see we have a horizontal line up right there. All right, so let's get back to the original graph. So that's a compression when the line is very close, less than the parent, in between the parent and the x-axis. So it happens negatively and positively. So let's go back to the last slide. Okay, so we have one more thing. So we want to go ahead and graph this one really quickly. So we have y equals f of x, it's x minus 2. So we go to -2. Our slope is 1, we rise 1, we run 1. Okay. So we end up graphing a parent graph that looks like this. So now when we compare this slope is a 0.25 equals 1/4. So that's going to be a rise of 1, run of 1/4. So from here we rise 1, run 1, 2, actually. Okay, so we rise 1/4. So we're shifted here. So from this point, we're going to rise 1, run 1, 2, 3, 4. So if that's correct, when we put G of, let's just put G of 2 in there, we should get 0.25 times 2 minus 2, which gives us a 0. So at G of 2, we have 0 here still. So that's why I knew where to start there. So the next point, we just take the slope over. So what that gives us is a new line that is compressed. So it's between the original line and it's close to the y-axis. Okay, so how does this compare? 0.5? Well, 0.5 is the same thing as 1/2. So 0.5 is 1/2. So from this same slope, there should probably be, oh, there is not parentheses there. So we're going to start from here, this point here, this y-intercept here, count the slope, rise 1, run 2, and we have another compression here. So this one is going to start from this intercept right there. That's a y-intercept. That is not a y-intercept. And there we have it. Have a great day. Bye-bye.